All right, today's lesson I'm going to call the anatomy of a parabola. I used to call it the parts of a parabola, but it makes it sound more alive when we call it anatomy. So, looking at this particular parabola, here's the origin. This parabola has been shifted away from the origin so that its vertex lies on a 3, -5. So there we get one piece of vocabulary we should already know. The vertex will be the lowest or highest point on the parabola. That is the point where the parabola turns around. Going through the vertex is what's called the axis of symmetry. The axis of symmetry is a vertical line which will cut the parabola into two equal halves. That is, if you fold along the axis of symmetry, you'll end up exactly on the other side. The axis of symmetry is a vertical line, and vertical lines have x equals as their equation. So we wouldn't say the axis of symmetry is 3, we would say the axis of symmetry is the line x equals 3. So be clear on that. We also have the Y-intercept, which is the value of the function at 0. We have x-intercepts, which we'll talk about more later. And finally, we have this thing I call the bonus point, which is just my own thing, but it's basically a freebie. I get a free solution to the equation if I understand my symmetry. So having a point at 0, 4, and an axis of symmetry at 3, then we can go over 3 and then over 3 more, and we'll be back on the parabola again. So in addition to 0, 4 being a solution to my equation, I also have 6, 4 as a solution. So what we're going to do is we're going to use all of these different parts of a parabola to help us with our work. Basically, our goal here is going to be to look at an equation and to be able to graph all the solutions to the equation as quickly and efficiently and accurately as possible. So quick and efficient are things that are going to happen over time, but for right now we're going to work on accuracy. So for starters, we're going to try to imagine what a parabola looks like that's been shifted left 2, up 5, and has no flipping or anything like that going on. So I quick draw and imagine in my mind's eye a parabola that's shifted over in this direction. So what this does, I expect students to think this way, but since I can't read your minds, thank goodness, I can actually ask you to write down what's in your minds by just showing me a little sketch with a thought bubble around it. So this tells me that you thought about the outcome before you started doing all the analysis. Now the analysis. First I identify the vertex. The parabola has been shifted, remember we went through this, left 2 and down or up 5. So I write -2, 5 as the new location of the vertex. Since the vertex goes, or the axis of symmetry goes through the vertex, I can identify the axis of symmetry as the equation of the line x equals -2. I know the y-intercept, and I can find that by finding f of 0. Notice that there's a little 5 dangling out here, but the y-intercept is not 0, 5, it's 0, 9, because f of 0 gives me the y-intercept, not just some number hanging out by itself. So we have y-intercept at 0, 9, which means we also can identify a bonus point at -4, 9, because the axis of symmetry is -2. If we double that, we have our bonus point. And there are no x-intercepts because I can see there are no x-intercepts. So what I do is I take the 3 points that I found, the y-intercept, the bonus points, and the vertex, along with the axis of symmetry, and I use that to draw my parabola. I advise you 2 things. Number 1, instead of trying to draw from the top and end up at the top, start at the vertex and draw the right half, start at the vertex again and draw the left half, and make sure that the bottom end is not pointed, rather that it flattens out. It's really subtle, but it flattens out before it turns around. As always, I wouldn't do any of this work unless I was checking on technology. It takes me an extra 20 seconds to open up a Desmos file and type in the equation as I see it, and I just verify that the points that I found are the same as the points on my graph. All right, so just seeing the same process over again, this is a template that you can use. I'm supposed to stop right there. This is a template that you can use so that your work will be the same no matter what, all the time. In other words, if you always have a thought bubble and you list the things you're supposed to find, then you just have to fill in the blanks. This is like a worksheet or something. So just as a quick thing, I look at opens down, stretched out, shifted right 2, down 1. So I'm going to get a parabola that's going to look something like that. Identifying all of my key features. Excuse me. Identifying all of my key features and putting together the axis of symmetry, which I'll also label x equals 2. I label the 3 key points, the axis of symmetry, and then I check with the computer and make sure that I'm getting the same graph that I visualized, and everything's all working. So that's all you have to do today. There'll be a series of parabolas, or sorry, quadratic functions written in this form, and you'll be asked to do the exact same thing that I showed you here. So follow this format, and this will be the easiest work you've done in a long time. Enjoy.